Hello there. What is a mole? A mole is a unit which measures the amount of substance. Focus on this word. Mole is a unit. Okay? The mole is symbolized by small n, and its unit is the mole written as mole, M-O-L. And the mole is one of the 7 base units in the international system. We have second, meter, kilograms, etc. And we have mole. So mole measures the amount of substance in chemistry. We are going to learn about the relationship between the mole and Avogadro's number. Let me ask a question. If you have 1 dozen of pencils, how many pencils do you have? Of course, you have 12 pencils. So, this word dozen expresses a specific number, which is 12. In the same way, in chemistry, 1 mole represents a specific number, which is 6.022 times 10 to 23. So if I have 1 mole of pencils or anything, 1 mole of tables, electrons, atoms, or anything, so I have 6.022 times 10 to 23 tables, electrons, etc. Okay, so called Avogadro's number is 6.022 times 10 to 23. But this number is very huge. In honor of efforts the scientist Avogadro, scientists agreed to name this number Avogadro's number, which means Avogadro did not discover this number, rather it was named for him. So we can replace this number with the Na, which means Avogadro's number. Examples: if I have 1 mole of sodium or 1 mole of carbon atoms, so I have Avogadro's number from or of ions or atoms. But if I have 2 moles of electrons, so I have to multiply by Avogadro's number. 2 here, okay, times Avogadro's number by substituting Avogadro's number 6.022 times 10 to 23. But by multiplying these numbers together and leaving this one out, so we will get there 12.044 times 10 to 23. If we have 2 moles of electrons, I have 2 times Avogadro's number of electrons, okay, or you can see this number. But if I have 0.5 moles of water molecules, so I have 0.5 times Avogadro's number. As we did previous example, we can multiply these numbers together and leaving this number out, we will get 3.011 times 10 to 23 water molecules, of course. Okay, so as a result, we conclude that 1 mole of any substance contains Avogadro's number of particles. In fact, there is a law shows the relationship between moles and Avogadro's number, which is small n equals capital N divided by Na, where small n numbers of moles of particles, capital N numbers of particles, and Na Avogadro's number, of course. But we can also find another law. From this law, we can also calculate capital N number of particles. But how? We can place capital N on one side and the rest on other side. We will give N, capital N, equals small n times Avogadro's number. So we can calculate number of particles from this law. Let's move on to the exercises. Example 1. How many moles are present in 1.204 times 10 to 24 atoms of aluminum? The question is to calculate the number of moles, as you see. How many moles? The given information is number of atoms and Avogadro's number, and the required information is the number of moles. First, we write the formula that relates the number of moles to the number of particles. Then we substitute the given values, capital N and Avogadro's number, in the formula into the formula. After that, we simplify the fraction and we finally obtain the result, which is 2 mole. What does mean this value? The result means there are 2 moles of aluminum in 1.204 times 10 to 24 atoms. Another example, how many sodium ions are there in 0.25 mole? We have given information. The required information is capital N, which is number of ions. In the same way, we write the formula, then we substitute the values into the formula, multiply these numbers and leaving this number out, we will get there this result 1.5055 times 10 to 23, which means there are this volume or this result sodium ions in 0.25 mole. The next one, determine the number of molecules present in 0.1 mole of water. In the same way, we have given information and required is number of molecules. We write the formula N equals small n or number of moles times Avogadro's number by substituting number of moles. Then we will multiply these numbers and leave this number out. We get this result. Then we can say there are 6.022 times 10 to 22 molecules of water in 0.1 mole of water. The last example, determine the number of atoms present in 0.1 mole of water. Notice that exercise. In this exercise is similar to exercise 3, if you notice that. But there are important difference, which is here we have to calculate the number of atoms, but in example 3 we have calculate number of molecules. These important note. Okay, why? Because exercise 4 asks us to calculate the number of atoms, while exercise 3 asks us to calculate the number of molecules. Okay, so this is an important difference. If we are asked to calculate the number of molecules, we calculate as we learned in the exercise 3 here. However, if we are asked to calculate the number of atoms, we must multiply by number of atoms in the molecules within the solution. Let's clarify that. We have number of moles and Avogadro's number. We substitute them in their place along with Avogadro's number, of course, and multiply 3 here. Why? Why 3? Because in a water molecule, we have 2 hydrogen atoms and 1 oxygen atom. If we added them together, we have 3 atoms in each molecule. Okay? Therefore, we multiply by 3 here and we get the result as you see. So there are 1.81 times 10 to 23 atoms in 0.1 mole of water. Okay, if we assume here, if we have another molecule other than water, like sulfuric acid, how many atoms are there? We have 2 here and 1 and 4 oxygen, as you see. If we added this, we have 7 atoms here. So we must multiply by 7 here, and we can continue this solution. Thank you for watching.